Hey, so if you're watching this video, it's because you're interested in building new skills for Optic. I'm going to warm you up real quick. There's three things you need to know about: lenses, transformations, and schemas. And this 7-minute video is going to walk you through around 2.5 to 3 minutes on each one of those things. So stay tuned, and once you're finished, check out the rest of the docs on useoptic.com. They'll help you figure out sort of where to go from the video. So this isn't going to show you too much code, it's just sort of a high level walkthrough of how all these different parts of the SDK fit together and what you can do with them when you're developing skills for Optic. So hope you enjoy. Thanks so much, and here we go. Lenses let you think about code as data. So for this section of code, Optic would parse it as a JSON object with an as field for defined as and a path field for path to. But what makes a lens special is that you're also able to update it. So if I change the JSON object, Optic will take the new values and use that to update the existing code. So I'm changing it to as Optic, and the path will be Optic MD, which is our markdown package. You'll see the code automatically updates. And this works with more complicated code too. So this is an example of a route in Express.js, and it gets a method field set as get, a URL for -hello, and there's one parameter. It's a query parameter called name. And just like before, if I update some of these fields, like we'll make get post, and we'll add world to hello, Object will figure out how to automatically update the code to match the new model. So once we're able to manipulate code like this, almost like it's a REST API, it opens up a lot of really interesting doors. So let's move the iPad over and let's just think about things we have in our app. So we're going to have this endpoint for hello world, but at some point we want to call this endpoint with an HTTP request. For a normal programmer, we're going to go through and figure out, just by looking, what the route is, what the parameters are, and all that. But in Optic, we use a transformation, which is basically a one-way function that will take this JSON object representing the endpoint and convert it into a JSON object that represents an HTTP request. These are typically very simple mappings that we all do in our head, but Optic's able to do it automatically. So here's the code you might get out when you generate a HTTP request using request.js that connects to the hello world endpoint we made. So I'm going to zoom in now. You can see that it gets the correct URL and it gets one query parameter called name. So now let's expand this thinking a little bit. Let's say that this endpoint was actually the create endpoint derived from a model. So we transform a model into all its different CRUD endpoints, in this sense of being one of them. So we'd also have another endpoint for read. We'd have an update one as well, and we'd have one for delete. We'd also transform all the HTTP requests in our client into forms. So we might have a bunch of those, and we also could maybe convert this model into some tests for the model. So you can have an entire app that's sort of laid out, and when you think about the hierarchy, most of the code you write ends up being derivative from another kind of code. What's difficult is manually mapping those things from one to the other. So let's get a lot more concrete with this. So we have our hello world route, and we know that that has one parameter called name. We also have a request that we transformed from earlier that's set up to connect to this endpoint. Now let's go in and imagine that we added a new parameter called last name, and we wanted to automatically update that. Well, since Optic understands how all these different parts of your code fit together, it's able to walk the tree and actually do a diff for you and figure out what you might need to change in your code automatically. So this is Optic's sync feature. So now you see, if we were to run sync, Optic would automatically figure out that, hey, we need to update the query string. And as you see up here, it added first name and last name. The same principle of using one kind of code to generate another and then keeping those relationships synced over time is possible for all parts of your code. It even works between your back end, which is represented as above the line, and your front end, which is below the line. So Optic can basically sync all the code in your organization automatically. So there's one final concept in Optic called a schema. Schemas are analogous to traits or interfaces in object-oriented languages. So we might have one for a route, a request, a form, some validation code, or even different kinds of auth schemas in our app. So there's a lot of ways we can make a REST API. We could use Express in JavaScript. We could use Flask in Python. But we really want to use the same schema for both of these. And that's because all of these schemas can be interconnected. So on the front end, we might have Axios as our HTTP request library, or maybe Request.js, or even doing a throwback to jQuery. Doesn't matter. What's interesting is if we use all of the standard schemas for these three, and for the routing library, all we need is one transformation. So we can go from Flask to jQuery, go from Flask to Request, Flask to Axios, and all we need to do is write a single transformation that converts schema A to schema B. And then we've connected all of these different kinds of codes. So there's an arbitrary number of REST libraries you could use, and an arbitrary number of HTTP request libraries, but they can all interoperate with each other using Optic as long as we have a shared schema. So in summary, Optic combines lenses, which turn your code into data, transformations, which help you turn one kind of code into another and sync them over time, and schemas, which make it possible to create generic transformations between a lot of different libraries. You bring all these things together and you've got Optic.